In my childhood, I particularly liked reading the books of Paul Devoy, who was an author in the style of Jules Verne. His best known book is Les Cinq Sous de l'Averade, but he also wrote another book called Le Docteur Mystère. This doctor had all sorts of unknown electrical devices. Thus, he had installed a screen that allowed him to see all the events that were happening in the world. For example, the Rio Carnival, the election of a President of the Republic of the United States of America, the July 14th parade at Longchamp, etc. This book had been written around 1900, so it was a prediction of a panoramic radar that saw not only through the clouds but also over the hills. It was in memory of the book Le Docteur Mystère, which had fascinated me in my childhood, that I named my first supersonic plane Mystère. Dassault's Mystère series rarely feature in aviation history outside of the francophone world, and as a mentioned but rarely analysed contributor to Israel's success in the 1967 war. Although they share a name, the Mystère series actually consists of 3 distinct operational aircraft and several significant variants. This video focuses on the first iteration, the Mystere II. Mystere II did serve as a frontline combat aircraft in the Armée de l'Air for a brief period between 1954 and 57. Its role in the Mystère line was to evolve the firmly subsonic Ouragan, which had straight wings and a Rolls-Royce Nene engine, into a supersonic fighter with swept wings and a more powerful engine. The Sol Mystère I changed the wings and other flying surfaces, but retained the Nene engine. Mystère II allowed a choice to be made between the reliable and powerful centrifugal flow Rolls-Royce Tay and the new French-designed and built axial flow Snecma Atar-101. As a result, Mystère II took rather a long time to develop and suffered from some quite lethal faults. It was essentially obsolete on its delivery in 1954, but was produced in some numbers to demonstrate that France was a serious player in aviation again, and to continue the restoration of the high-tech manufacturing industries and skills it had lost during the Second World War. Mystère II therefore can't be ignored if we want to understand more about Mystère IV, the Super Mystère, and of course the Mirage. And in truth, the Mystère II was definitely not Dassault's first disappointment. Marcel Bloch's first pre-war fighter, the Bloch 150, was so bad that it initially refused to fly at all. The MB 151 and 152 that were developed from it did ultimately take off to engage the superior ME 109, but to no avail. France fell, and with it their aviation designers entered a 5-year period in the wilderness. Bloch himself was sent to Buchenwald, but he survived and under his nom de guerre returned as Marcel Dassault. Gathering some of his old design team around him, he persuaded the French Ministry of Aviation to allow him to develop a relatively conservative, straight-winged fighter powered by the excellent Rolls-Royce Nene turbojet. This aircraft, the Ouragan, was unexceptional, but it proved that the French aviation industry could indeed build a combat aircraft rather than just fantastical studies and experiments. It looked rather like an F-84 Thunderjet, but stubbier, more angular and closer to the ground. Finished to a high standard, it had a stressed aluminium skin, a pressurized cockpit complete with ejector seat for the pilot, and a powerful battery of 420mm Hispano 404 cannons in the nose. In July 1949, a first batch of 15 MD-450 pre-production Ouragans was ordered, followed by 350 aircraft for the Armée de l'Air in 1951. India ordered 104 aircraft and Israel 24. The latter would eventually purchase a further 51 aircraft from French stocks and use them extensively through to the 1967 war. The late start to jet production meant that the conservative Ouragan was obsolete on delivery. Dassault knew this as he was keeping a close eye on developments in the US, Britain, and where possible the Soviet Union. The challenge of the sound barrier had captured the public's imagination since the end of the war. Unfortunately, getting through it was proving a significant challenge. Part of the reason for this was that a lack of high-speed wind tunnels meant that the only way to investigate transonic and ultimately supersonic flight regimes was to build aircraft, fly them close to the speed of sound, and see what happened. The barrier was broken for the first time on October the 14th, 1947, by Chuck Yeager in the Bell X-1. But even by the end of the 1940s, the total time a manned aircraft had flown at supersonic speeds in a controlled manner was measured in tens of minutes. Data was not readily available, and certainly not to the French designers. Their only option was therefore to make their own experimental aircraft. The other problem facing the French in 1950 and 51, when decisions needed to be taken, was that the British Hawker Hunter was making progress across the Channel. The Supermarine Swift at this point also seemed that it might be a good aircraft. In the NATO context, these were France's competition for export orders, alongside the Sabre and its successors. The economic downside of delays in getting a swept-wing fighter into production therefore hung over the program and put pressure on military and political leaders to make a decision. Even if a suitable airframe could be produced, there was the pressing issue of the engine that would power it. Ouragan had the excellent Neen, but although Hispano-Suiza believed that they could get more power out of it, the design was realistically approaching its thermodynamic limits. Fortunately, Rolls-Royce had an enlarged, more powerful centrifugal motor producing 7,700 pounds of force called the Tay in development. But basic analysis suggested that the Hunter was superior to a Tay-powered swept-wing Ouragan. As well as better performance, it would have more powerful armament, and the French feared a radar-ranging gun sight. That said, the Hunter could well be delayed, and using the Tay limited technical risk for any French fighter. Unfortunately, by 1951, it became clear that actually acquiring Tay engines would be quite challenging. Rolls-Royce had decided not to mass-produce it, seeing the future in axial flow engines. Hispano-Suiza could always make Tays in France, as they had done with the Neen, but establishing a production line would take time. The same engine was available as the J-48 from the Americans, but the French would shortly discover that rather than simply license producing the Tay, Pratt & Whitney had replaced and re-engineered basically every component. It wasn't the same engine, and it wouldn't even attach to the same mounting points, let alone share the rest of the kit needed to make it run. As well as this, there was a local alternative to consider. The German engineers at Snecma, the nationalised entity formed from the famous Gnome-Rhone engine company, had produced a 6,000 plus pound force motor called the Atar-101. On paper, this seemed promising, although it was axial rather than centrifugal and thus a totally different layout. Snecma had great people, but they were unproven as jet engine manufacturers. For this reason, Dassault was invited to design an aircraft that could take either the proven Tay or the unproven Atar. Marcel Dassault thus signed a contract for the study and production of a thin-profile wing that could be attached to the fuselage of an MD-450 Ouragan in February 1950. To meet the growing needs of the studies, hiring accelerated, including young Serge Dassault, fresh out of technical college. The French Defense Ministry's very optimistic October 1950 plan consisted of 520 MD-452s with Tay engines and 540 MD-452s with Atar engines. Production was due to start in 1951. Their later plan for France's contribution to NATO in 1954 required 786 452 Tays and 1,109 452 Atars, produced at a rate of between 30 and 40 aircraft a month. That would have required the entire French aviation production industry to operate at essentially a wartime level for an extended period, and it was patently unrealistic, not least because they didn't actually have an aircraft to build yet. To that end, Dassault and Company got back one of the 15 pre-production Ouragans, and they set about designing improvements to its aerodynamics. Still built in a single piece, the new wing had a sweep of 32 degrees at the leading edge, shifting to 30 degrees at the quarter chord, versus 14 degrees in the Ouragan. The inner half of the trailing edge was occupied by a flap, the outer half by a constant chord aileron fitted with trim tabs. The trailing edge and control surfaces of the vertical stabilizer remained similar to those of the Ouragan, but the leading edge had its sweep increased from 43 degrees to 50 degrees, which led to an increase in tail area of more than 20%, which was necessary to provide improved stability at transonic speeds. The horizontal stabilizer, which retained its layout, also had a sweep increase to 32 instead of 21 degrees, and the surface increased in size by 10%. The fuselage was 0.37 meters or a foot and 4 inches longer, to improve high-speed stability. Otherwise, it retained the circular cross-section and construction of the Ouragan. The engine was still a Rolls-Royce Nene at this stage. Dassault's approach was typically conservative. He didn't jump to the eventual answer, rather he iterated towards it. This was at odds with other French designers who continued to propose madcap schemes well beyond the ability of the French aviation industry in this period. Before getting to the many iterations of the Mystere II, I'll summarise its general construction and layout as this was common to all of the variations. Like the Ouragan, it was an all-metal low-wing monoplane. The fuselage was built in two sections, made of a hand-formed aluminium skin over 27 frames. It was bolted together at frame 16, a few feet behind the pilot, to allow the rear to be removed for engine maintenance. The pilot sat between frames 4 and 12, with the nose landing gear underneath him. His cockpit was made of thicker gauge aluminium to retain pressurization. The wind shield ahead of him was made of 40mm triplex bulletproof glass. The rest of the canopy, which was originally side-hinged and later a clamshell, was made of 22mm plexiglass. Armour protection for the pilot consisted of 16mm steel plates in front and behind him and behind his head. The side-hinged canopy was manually operated. The clamshell was electrically driven with a chain drive and would eventually have a pyrotechnic system for emergency release. The wings were different from the Ouragans, but they shared the same construction technique, being built around 2 iron spars and in this case 10 ribs per wing. The aluminium wing skin tapered, getting thinner near the wingtips to save weight. All Mysteres have a single tail, although there were many different tweaks to its size and layout. It's a separate structure attached to a stump on the fuselage by another 2 iron spars. When avionics were fitted, the VHF antenna sat on top of the tail. The rudder took up most of the upper portion of the fin. It could deflect up to 22 degrees, was powered by an irreversible hydraulic system, and had a spring-based feedback system that also centered the rudder when there was no pressure on the pedals. Elevators and ailerons were initially unpowered, gaining hydraulic assistance from very early in the test program. The elevators could deflect from +10 to -18 degrees. There was no dihedral on either the wings or the tail. Landing gear was a conventional tricycle type, very closely related to that on the Ouragan. There were disc brakes on the main gear for slowing the aircraft down on the ground. The first prototype weighed 11,620 pounds empty and 14,220 at takeoff weight, with ballast replacing the 420mm cannons under the nose. It was completed at the end of 1950 at the St. Cloud workshop, and then transported by road to Istres because the runway at Dassault's own test facility was too short. Its first flight was on the 23rd of February 1951, with the famous Kostya Rozanov at the controls. MD-452 immediately showed significant gains in rate of climb and maximum speed compared to the Ouragan. It could get to Mach 0.87 versus 0.77 in the Ouragan. There were, however, some issues. Foremost was the weight of the unassisted controls at speeds above 200 miles an hour, and enough tailplane flutter to worry Dassault as structural failure was a lethal feature of early transonic experiments. Inevitably, adverse yaw appeared at speeds above 500 miles an hour, and the aircraft wanted to drop a wing at 0.81 Mach. To remedy these issues, Dassault immediately had his team develop a customized, hydraulically powered control system for the MD-452. This used a single pump in the fuselage and exerted 1,500 kilograms of force on the ailerons and 1,000 on the elevators. He also moved to the test center so that he could direct work on aerodynamic adjustments personally. Marcel was a quick learner and quite intuitive about the issues of an aircraft despite not being a test pilot himself. He would take Kostya Rozanov aside and have him go through a simulated flight with him. Rozanov narrated what he did and what he felt in the aircraft so that Dassault could understand what was happening. Dassault also spent a great deal of time with the engineers on the ground, making himself the bridge between flight and design. He was the main instigator of tweaks to the length of the fuselage and the wings and the dimensions of the control surfaces. The engineers then put them onto paper, into the metal, and onto the plane as fast as possible. To go even faster, the engineers ran 2 shifts, with Dassault passing on instructions to the foreman so that things could be started overnight. All of this hard work paid off in April 1951 when the Directorate of Aeronautical Construction ordered 17 pre-production aircraft intended to test the different types of engines and weapons envisaged for the service fighter. Then, in August 1951, Dassault received an order for 50 aircraft powered by the TEI and 190 with the Atar-101C. At the same time, he got an order for development of a more advanced version, which, as the Mystère IV, would restrict the number of Mystère IIs that would be purchased and the length of its service life. Prior to work starting on them, an American delegation visited Dassault to fly the MD-452 in September 1951. They were complementary in a sense, although their main observation was that the Mystère compared well to the aging F-86A Sabre. The Mystère had equivalent turning performance at medium altitudes and was superior at high altitudes. They also noted that some of the Ouragan's less favourable traits were retained in the Mystère, though. Most obviously, the stall boundary was very sudden and the air brakes were almost completely ineffective. The Americans were there, incidentally, because much of the development of the Mystère had been funded through the Military Assistance Program. The second and third Mystère prototypes had the TEI, and they were designated Mystère II-A. The second aircraft had wings of greater width at the root, leading to increased area. The horizontal tail was also positioned lower down the rear fuselage based on the lessons learned so far. Internal fuel capacity was increased to 404 gallons, with 188 in the wings and 216 in the fuselage. A Sabre had roughly the same depending on the version. Aircraft 3 was further lengthened, this time by 15 centimetres. It had enlarged air brakes that could deflect to 70 degrees. Visually, though, it's quite hard to pick these aircraft apart. I believe that Aircraft 3 was the first one to carry cannons rather than ballast. Aircraft 2 and 3 flew on the 5th of April and the 2nd of July 1952, respectively. Dassault's aerodynamic tweaks made them more stable at transonic speeds, more resistant to wing drop and easier to recover from spins. Aircraft 3 was used by US pilots to break the sound barrier in October 1952. Apparently they were surprised that the French hadn't told them that the MD-452 was now supersonic. The Dassault team were even more surprised, as they didn't realise they'd been diving to supersonic speeds in their testing. The US pilots showed their French allies how to direct the bang so it could be heard on the ground, with the result that Commander Roger Carpentier was able to become the first Frenchman to fly supersonic on December 12, 1952. He was followed into the history books by Jacqueline Auriol, who became the first French woman to go beyond the sound barrier on August 15, 1953. Sadly, in between these events, a March 3, 1953 crash killed the test pilot Charles Monnier. He was flying Aircraft 2 during a low-level wingtip tank jettison test when the right tank hit the vertical stabilizer on release, destabilizing the aircraft and causing it to crash. Remarkably, it was the first time that Dassault and previously Bloch had lost a pilot in one of his own aircraft. Within the month, Aircraft 3 was also lost, either during a demonstration for an Indian Air Force delegation or perhaps in preparation for it. Its pilot attempted a high-speed dive at low level, lost control and crashed before he was able to eject. Aircraft number 4, the last of the purely experimental prototypes, had taken its first flight on December 28, 1952. Besides the Atar engine, it was armed with two 30mm DIFA cannons and was designated Mystere II-B. The TEI had proven to be a powerful and reliable engine, albeit one that liked to drink. One downside was that it didn't give a very linear power curve, presumably because of the large rotating mass inherent in a big centrifugal flow engine. And of course it was British. To fit in the French Atar-101, the fourth prototype was a foot longer at the front and about 1.5 inches shorter at the rear. The rear fuselage also bulged more prominently because the engine was longer, but the front fuselage cross-section was kept the same despite the fact that the slimmer engine couldn't make use of the additional volume. 30 gallons of extra fuel was carried in the spare space. The 6,150-pound force Atar-101C was 35 inches in diameter versus 50 for the TEI, but the Atar was 145 inches long versus 103 inches on the TEI. Extra aircraft size meant that Aircraft 4 was 200 kilograms or 440 pounds heavier than Aircraft 3, even though the engines weighed almost exactly the same. Not committing to one engine or the other therefore compromised the design's ability to make use of a less draggy profile. All up, the first MD-452 Atar weighed 13,050 pounds, nearly £1,500 more than the Tay aircraft. After the first flight, the Atar 101C was replaced by an Atar 101D featuring an axially translating jet pipe bullet similar to that on wartime German fighters. That process took until April. When flights resumed, they offered the first glimpses of the many difficulties that were to follow, such as snaking when the rudder was pressed. Performance was better than the Tay aircraft, although the Atar 101D was far from trouble-free. It was hard to relight in flight and suffered from resonance that caused power surges and what the pilots described as a mooing sound. And, of course, it still liked to drink too, which made flights short and, because of the lack of reliability, infrequent. Only 60 flights took place in the year before the tests concluded in March of 1954. In that time, it did, however, demonstrate that it could climb to 50,000 feet and then exceed Mach 1 in a dive without suffering from significant wing drop. Longitudinal stability was still not good, though, and steep climbs had to be undertaken with care if the pilot didn't want to end up in a spin. Dassault and the Armée de l'Air faced a decision. They could either risk deploying the Atar-engined aircraft with its superior performance but low reliability and limited range, or they could produce a Tay-engined aircraft that, although an upgrade over the Ouragan, did not have spectacular performance and it had a British engine, complicating matters with the Mystère IV, which had started flying with a Tay engine in September 1952 and was obviously superior to both, albeit further away from service. The decision still wasn't made when construction of the pre-production aircraft began. Aircraft 5 and 6 were Tay-powered, but with lengthened fuselages in comparison to the two initial Tay aircraft. They had four 20mm cannons aimed with a gyro gun sight and an updated nose wheel design in which the wheel was steered via the rudder pedals. This made them Mystere II A's rather than B's. Aircraft 5 took its first flight on November the 5th, 1952, but again it was immediately removed from service to increase the height of the vertical fin by 6 inches. Although control of wing drop during high-speed dive tests was improved still further, the boosted controls continued to give problems. We think of these systems as being relatively simple, but at this point even figuring out what hydraulic fluid to use was a sticky problem. Literally in this case, as Dassault's system tended to get blocked in the cold at higher altitudes. An in-cockpit switch to disable the system was fitted so that pilots could get rid of it if they needed to. Aircraft 5 was also used to test out Hispano's first license-built Tay, called the Verdun. Aircraft 6 was the same as Aircraft 5, but with an SN Casso E86 ejection seat rather than the Martin Baker units fitted to the other aircraft. This change was not popular with the test pilots, as the bulky E86 reduced rearwards visibility. Pilot situational awareness was an issue with the Ouragan, and it was actually worse on the Mystère. Aircraft 6 flew a day before Aircraft 5, and it was lost in a non-fatal belly landing in May 1953. 7, 8, and 9 were the same as 5 and 6, with the exception of switching the 420mm cannons for two 30mm weapons. From Aircraft 7, these were, I believe, regarded as Mystere II Cs, as they were supposed to be representative of the production MD-452 Tay. If you're getting a bit confused about all of these different versions and variants, you're getting a real sense of the nature of the Mystère program. I also apologise if I've got the wrong end of the stick on the exact number and nature of the various prototypes. All of the sources are in French, and my French is not all that great. Aircraft 7 flew extensively. It was the first to attempt air-to-air firing of the weapons, which went fine, besides issues with quality control and the ammunition links of the experimental DEFA cannons. Aircraft 8 was supposed to get a J-48, but when it arrived, it didn't actually fit the aircraft. Consequently, it never flew. Aircraft 9 was built with the Dassault automatic tail, equivalent to the Sabre's all-flying tail. The rear fuselage was heavily modified and the takeoff weight climbed to £16,000. £1,800 had now been gained since the Mystere I's first flight. Pilots liked the automatic tail, which also automatically applied the appropriate deflection dependent on Mach number. It was, however, removed and replaced with more conventional surfaces when Aircraft 9 went to the Air Ministry for trials. The Atar aircraft were 10, 11, and 12. They had 30mm cannons and they were broadly similar to Aircraft 4. Number 10 flew for the first time on March 3rd, 1953. It had gained another £300 loaded, up to 16,350, and it was not fast. initially failing to get beyond 0.7 Mach in level flight. In August 1953, the guns were installed and an Atar-101C3 engine with what the test papers describe as a restricted nozzle was fitted. It did a round robin of test venues and teams, and then in late 1953, 150-litre tip tanks were fitted. Nothing cured the vibrations, although they were pushed back to 0.82 Mach. In an attempt to reduce them, the short tail was extended by a meter-shaped fairing, and the rear fuselage was generally reworked. Wing drop, which had been worked out of the Tay aircraft for the most part, was severe for those brave enough to get up to Mach 0.9 in the Atar aircraft. It was sufficiently dangerous that testing of aircraft 10 was paused for a time. When it resumed on the 27th of June 1954, on its 117th flight, the aircraft, piloted by a Lieutenant Tesson, departed controlled flight while exiting a supersonic dive at around 20,000 feet. Lieutenant Tesson tried to eject, but the sliding canopy stuck partway open because there was too much play in the canopy release mechanisms. He was fatally injured when he hit the frame during his ejection. An explosive canopy release system had been developed and it was fitted to aircraft 13 alongside the clamshell-type canopy, but it hadn't been retrofitted to 10 by the time of the accident. Aircraft 11, which flew in June 1953, was also a poor performer. It had the fixed nozzle Atar-101C from the outset and was later fitted with the 101D, which did little for it. Aircraft 11 was also lost in a fatal crash on June 15, 1956. 12 was similar. It survived to become an engineering study example at the Rochefort School at the end of its flight test career in 1956. Perhaps one of the students eventually discovered what had gone terribly wrong in the attempt to turn the best of the Mystere II prototypes into a service fighter. 13 followed the same pattern, but was instead preserved as a static display aircraft. After these disappointments, for the next pre-production aircraft, Dassault chose to take the American test team's earlier advice and fit a different wing. This was a NACA 65009 aerofoil, and it had a symmetrical profile. Otherwise, aircraft 14 was identical to 12 and 13, and it was powered by an Atar-101D. The wing worked in one sense. Wing drop was substantially reduced. Unfortunately, overall vibrations at even modest Mach numbers were violent and proved impossible to eliminate despite the addition of vortex generators on the ailerons, experimentation with different tip tanks, and so on and so forth. It eventually flew 350 times before being retired in 1956. Aircraft 15 first flew in November 1953, was used for drop tank tests, still had poor performance, and disappeared into history sometime around 1956. Aircraft 16 had a short career, being written off in a non-fatal accident in February 1955. Aircraft 17, by contrast, was the most used pre-production aircraft besides 14. It was used to test wing hardpoints, of which there were 4. The inboard ones were plumbed for drop tanks, the outer ones for bombs and rockets. Strangely, carriage of external stores hadn't initially been considered for the Mystère. It was intended to perform intercepts in clean condition. Wing hardpoints added tactical flexibility, as well as heavy 500-pound bombs on the inboard pylons. In total, up to 550 gallons of extra fuel could be carried between the larger wing tanks and the tips, significantly extending endurance. Dropping things off 17 was therefore a frequent part of the test program. It turned out that the pylons increased the speed at which wing dropping occurred as they acted like wing fences. Drag was the obvious downside of this effect. Later upgraded with an Atar-101D, it would fly until 1957, and by that point was as close as any of the pre-production aircraft came to being like the Mystere II-C. Aircraft 18 was the last pre-production model and went to the Air Ministry in September 1954. There were then 2 additional aircraft built prior to production. Both 19 and 20 were used to test the Atar-101F engine, which had an afterburner. You can see the distinctive can on this image of 19, which flew with it in May 1954. Although it doubled climb rate at all altitudes, instability meant that the aircraft was rather challenging and scary to fly above Mach 0.7. Installation of vortex generators on the rear fuselage was supposed to fix the problem, but it didn't, and the aircraft was eventually stored at Snecma in 1956 and forgotten about. 20 had much the same career. It survived an afterburner fire on the ground in 1954, returned to flight, and then vanished into storage in 1955. As you can see, development of the Mystere II was a sorry tale. It was an unfortunate aircraft, in that it had been designed to take the Tay but was fitted with the Atar, causing acute centre of gravity issues. The Mystère II was pursued because of the strategic need to develop an indigenous French engine, even though this delayed procurement of an aircraft for 3 years and the result was a disappointment. It would later prove to be a good decision as the 101G and later models, like the Atar 9, would power 2 generations of supersonic fighters. Production orders for the Tay and Atar Mysteres had been placed in 1951. Manufacture of tooling to produce both types was well underway by late 1952, but then in January 1953 all work on Mystère 2C production engineering was stopped. That left enough equipment to produce a dozen Atar-engined aircraft a month. Tay aircraft tooling was scrapped along with the half-dozen aircraft that had already been constructed when the final notice of termination came in September. Tool orders placed with Snecma enabled them to build 40 engines a month, although the first order was for only 100 engines at a rate of 20 a month. That was placed in February 1952 for the record. After much toing and froing, it was eventually decided not to scrap the 36 Atar aircraft that had been produced and to extend the order to 150 units. 24 of these had been ordered by the State of Israel, but that order would eventually be switched for Mystère 4s in December 1955. You might reasonably be wondering exactly what design was ordered in April 1953. At the encouragement of the US mission, the symmetrical wing profile was selected for production. The overall aircraft weighed 7,400 kilograms or 16,300 pounds at normal takeoff. Loaded up with 425-litre tip tanks and up to 500 kilos of stores under each wing, it could reach 9,100 kilos, a shade over 21,000 pounds in old money. It was therefore between the original Sabre and the Sabre Hog in weight, although without the Hog's power and lifting capabilities. The motor in production aircraft was a Snecma Atar 101D2, a D2A or a D3, depending on the aircraft. These variants differed in the nozzle design, with the D2s having an eyelid design and the D3 a pneumatically controlled restriction device. D3 also had a high-energy ignition system that enabled relighting at altitude. When this device was fitted to 101D2s, they became D2A. Theoretically, these engines were interchangeable, subject to minor modifications to the aircraft. 56 or 57 aircraft were equipped with eyelid nozzles and all the rest had D3s. The Atar 101D consisted of a 7-stage axial compressor, an annular combustion chamber and a single-stage turbine. The nozzle outlet section was controlled by a regulator and modified by the eyelids or the restriction device. The engine was electrically started. Overall, 101D was 12 feet long, 3 feet in diameter, and it weighed 2,350 pounds. D2 gave 6,050 pounds of force, D3 gave 6,480. For comparison, a J4725 was 12 feet long, also 3 feet in diameter, and it weighed 2,500 pounds. It produced a shade under 6,000 pounds of force. J47's development preceded Atar 101 by 5 years or so, but Snecma had managed to get somewhat close with their first fighter engine. Fuel came from tanks in the wings and fuselage. They were self-sealing and they could seal hits from up to a 12.7mm round. The Mystere's own gun system consisted of two 30mm DEFA 541 revolver cannons, aimed via Dervaux 148 radar ranging gun sight. There was a backup gyro sight as well. Ammunition came from a single can per gun mounted above the cannons. Spent rounds were ejected below the fuselage with a deflector keeping the rounds from hitting the aircraft. Gun gas was vented through 8 louvres in the gun bay door. The location of the weapons relative to the air intake appears to have prevented any serious gas ingestion issues. The gun camera was a Fascine 72, and it was mounted at the top of the air intake center partition. The Dervaux TE3 Type 148 radar rangefinder operated at 3cm wavelength, emitted and received via a candle-type antenna mounted on the top of the nose of the aircraft. Locking and tracking were automatic, and the pilot could select between targets. It was judged to be effective between 250 and 2,400 meters. The first production aircraft didn't fly until October 1, 1954. Unsurprisingly, given everything that was going on with the pre-production aircraft, the early Mystère II-C was a failure. 25 were made and all were deemed unfit for service. This resulted in a crash program to determine what was wrong and to fix it. The fixes consisted of the installation of new horizontal and vertical tail surfaces, practically identical to those on the Mystère IV. The rear fuselage was also changed to something more like that of the IV as well. Tip tanks were removed. An experiment with a smoothed wingtip proved useless, so the tips were left blunt. Aircraft could instead carry 625-litre conventional drop tanks. This schematic shows how the tail developed from Mystère I through the pre-production IIs into the final II-C with the Mystère IV tail and rear fuselage. There were other changes to the control surfaces before an apparently workable design was finalised in March 1955. 45 further aircraft were built in 1955 to the old design, all of which had to be returned to the factory and remanufactured. Many Mystère IIs were essentially made twice. Half of the batch for Israel was completed when their order was adjusted in 1956. Since they had Israeli avionics and IFF specifications, these items all needed to be removed and replaced if they were to be useful to the Armée de l'Air. That process took until 1957. As production went on, more modifications were made and subsequently retrofitted to the existing aircraft. Of particular note was the fitting of larger air brakes and the removal of the outer wing hardpoint. Internally, changes to connectors and avionics like the IFF to correspond to NATO standards were also needed, since the premise of the Mystère was that it would be a common fighter for other NATO countries to adopt. Despite the improvements that had been made, production Mystères exhibited consistently odd flight behaviour. For example, it was more difficult to provoke a spin than in the second pre-production aircraft, but once you were in one, it was harder to get out of it. The sixth production aircraft was lost this way in June 1955, but fortunately the factory test pilot was able to eject. This was around the time the Mystère IIs were entering squadron service. Service entry tests appear to have been taking place in parallel as high-speed cannon firing wasn't cleared until the summer of 1956. Shots were taken at up to 0.95 Mach and 40,000 feet. Mystères were deployed in squadrons of 25. A wing would typically have either 2 or 3 squadrons, which is a lot of aircraft to construct and deploy. The 10th Wing was the first to receive aircraft, starting in December 1954, but rather than arrive in bulk, they trickled in at an unpredictable rate. The 10th Wing was new and formed primarily of reservists. I cannot really envy them the experience of having to learn their jet fighter trade in such a finicky ride. On the opposite side of the experience spectrum were the 5th Wing, which started to receive their aircraft in 1956, replacing Mysteres, which were vampires up-engined with Neen engines. Some of the Mysteres were those originally ordered by Israel. The 5th were combat veterans who had used their Mysteres extensively in counterinsurgency missions in North Africa. Fortunately for them, they would not be asked to do the same with the Mystère II. Basically, the II-C was not a very well-liked aircraft by the pilots that flew it. Its imperfect aerodynamics were the first limitation. It was a stressful aircraft to fly, particularly at speeds above Mach 0.8. It would drop a wing without warning at higher speeds, making cruising less relaxing than it should have been. The hydraulics for the servo controls tended to run dry during maneuvers, making the controls suddenly go sticky from the pilot's point of view. At low altitude, the aircraft could abruptly run out of lift and stall out. Those were the most serious issues, but there were many more. The Mystere II shared the Ouragan's weak canopy, which would randomly crack above 15,000 feet, leading to a loss of pressurization. It was vulnerable to crosswinds on landing because the track was too narrow and the tyres were prone to bursting. Fortunately, belly landings were easy to execute, and the aircraft was as tough as the Ouragan had proved to be. French industry was not capable of manufacturing a precision item like a transonic fighter with the metronomic reliability of the Americans or even the British. And an inspection team found that in early deployments, fully 2/3 of failures were due to incorrect manufacture. On the plus side, the Mystère II's on-paper statistics looked promising. It had a marginally lower wing loading than a Sabre and 10% higher thrust to mass. But those characteristics don't translate into performance because of poor aerodynamics. Its 660 mph top speed is 27 miles an hour slower than an F-40 block Sabre. Climb rate was only half as good at 4,500 feet per minute versus 9,000. clean, its climbing ability was also tempered by the constant risk of a spin. With the drop tanks that were essentially mandatory for any flight beyond the boundary of the airfield, climbing performance was dreadful. It took more than 22 minutes for a Mystère II to climb to 40,000 feet when carrying tanks and a full load of ammunition. A purely horizontal turning fight was its only chance to use its powerful cannons. Unfortunately, the MiG-17F was just as good in that department. Also unfortunate was the Mystère II's poor performance as a gun platform. In tests, the guns couldn't be fired for extended periods without jamming, and accuracy was notably worse than results achieved with the de Havilland Vampires that the Mysteres had replaced. To cap it all, the new radar ranging gun sight was unreliable and a maintenance hog, as was the Atar engine, which still drank fuel at a prodigious rate and required the aircraft to keep a very close eye on the fuel levels in his tanks, as the feeder could easily run dry if he neglected to switch from one tank to another. The bottom portion of the fuel tank was unusable because of the position of the pump. Furthermore, low availability rates compromised effectiveness in any wartime scenario, and had a damaging effect on pilot training. The problem was significant. Between August and September 1957, the 10th Wing was supposed to have 60 aircraft, but it only had 48 on strength. Of these, only 8 were serviceable on any given day. The best availability rate the Mystère II ever achieved was 61%. The average was 30%. Pilots therefore picked up only a few hours, an average of just 10 to 13 a month throughout 1957, or between 120 and 169 hours in the year against a NATO minimum standard of 240 hours a year. Even when they were flyable, most Mystère IIs were not fully combat capable. In June 1957, the 5th Wing had spent 2 years flying the type and had 57 aircraft on strength. Of these, 46 were capable of carrying drop tanks because the others lacked the appropriate pins to secure them. Without tanks, the rest were basically useless for anything other than point defense. With internal fuel alone, a clean Mystère II could travel only about 240 miles after launch for a mission duration of 27 minutes. Its tanks would be basically dry by that stage, containing only 65 gallons, most of which was unusable because of the pump issue. Returning to equipment availability issues, only 26 of the 57 had their IFF gear in working order, 38 had not received essential hydraulic modifications to correct the dry running issue during turns, 14 didn't have working wheel brakes due to a lack of various spare parts, 13 didn't have guns, 8 lacked sensors that monitored non-essential things like airspeed, and fully 51 lacked gun cameras. Even basic repairs sometimes took far longer than expected. One aircraft required 160 hours of labour to replace a canopy that should have simply unbolted. Snecma and Dassault engineers were deployed to bases to create miniature depots that performed maintenance, but the issues still defied resolution. By 1958, the General Staff had had enough, and they decided to retire the type between March and May that year. Some of the airframes were essentially brand new at this stage. Some had flown less than 20 hours. Number 105 only had 10 hours on its airframe. Only 4 had exceeded 500 hours, the record holder being number 26 that had 559. Even so, most aircraft were scrapped, with only a few retained as training hulks in engineering schools. 11 aircraft had been lost in flight accidents, many others had been written off in accidents on the ground. It was initially replaced by Mystère IVs and shortly thereafter by Super Mysteres. There were no export orders for the type, despite some Indian interest and the cancelled Israeli orders. A photo reconnaissance version was proposed in 1952 but didn't get off the drawing board. It retained 2 20mm cannons on one side of the nose with the cameras on the other. The recon version would have used the same side intakes and enclosed nose as the 2-seat Mystère III Night Fighter, a prototype of which flew in July 1953. This would have had radar and rocket armament, but it never saw production due to the hectic pace of development going on around it. Amazingly, Dassault also proposed a carrier version of the Mystère II. It had shorter wings but also large leading-edge flaps to improve low-speed performance. Strengthening of the airframe and landing gear meant that normal weight grew nearly 2,000 pounds to over 18,000, but like the photo version, it never got into the metal. So that was it for the Mystère II. It spent more time in development than in service. When it was in service, most jets spent their time in maintenance or being rebuilt so that they could go back into maintenance with some other problem. If he'd been called into action against a contemporary Soviet built fighter flown by a competent pilot, a Mystère pilot would have been in a difficult situation, particularly if he had had to jettison his tank some way from base. I generally try and find something good to say about every aircraft I research. This, it must be said, is a hard one. It taught Dassault some things about transonic flight, but not as much as the Mystère IV, which was developed in parallel. 171 Mystère IIs were built on the basis that they would be useful for training pilots in transonic flight, but the two was neither transonic nor able to provide sufficient flight hours for training purposes. One thing we can say is that the French military was decisive in removing it from service, and they were also decisive in getting successive waves of new aircraft into operation in the 5 years that followed. The Mystère II was therefore part of a successful strategic system of aviation procurement, even if it was an engineering disaster.